All right, this guy right here, 1.2, modeling quantities, right? In general, when you're talking about quantities, you're talking about rates, ratios, proportions, or all of those are another way of saying fractions, right? And when we're talking about these guys down here, if you read through with me, let's do it, right? It says a ratio and proportion are very useful when solving real-world problems. A ratio is a comparison of two numbers by division, a fraction, right? An equation that states that two ratios are equal is called a proportion. So if I say one ratio, one fraction, it's the same as the other fraction, they're proportionate, they're proportions. This guy says a totem pole is 90 feet tall, right, and casts a shadow that's 45 feet long. We can see it over here, right? At the same time, a 6 foot tall man casts an X foot shadow. No idea how long that X is, right? But we can create ratios, and since they're the same, we'll be able to solve, all right? The man and totem pole are both perpendicular to the ground, so they form right angles to the ground. The sun shines at the same angle, and that's why this is proportionate. So it says write a ratio of the man's height to the pole's height. Well, let's do it. Let's put the man's height on bottom and the pole's height on top. I'm sorry, man's height on top, pole's height on bottom. The man is 6 feet tall, and the pole is 90 feet tall. It says write a ratio of the man, so we're going to put that on top, to the pole's shadow. Well, the man's height is, or the man's shadow is X, and the pole's shadow is 45, right? So we've just compared height to height and height of the shadow to the length of the shadow anyway. So here we go. We're going to write our proportions over here. We're going to say they're equal. The man's height of 6 over the pole's height of 90, right, is equal to the man's shadow of X over the pole's shadow of 45. All right. So solve the proportion by multiplying both sides by 45. So if I multiply this side by 45, right, I multiply this side by 45, I get this equation. Let's write it out here. 45 over 1 times 6 over 90, right? That's what's on the left side of this proportion because there's an equal sign. X over 45 times 45 over 1. On this side, the 45's cross off. On this side, I could go through and multiply by 6, but I notice I can reduce these fractions first. 45 goes into 45 once, and 45 goes into 90 twice, and 6 divided by 2 is 3, right? So when we solve the proportion, the man's shadow length is 3, which kind of makes sense, right? 45 is half of 90, so 3 is half of 6. Not too bad, right? What is another ratio that could be written for this problem? Use it to write and solve a different proportion to find the length of the man's shadows. So I'm going to talk about a couple things, right? As long as you're comparing same to same. So what if I said, you know what? I'm going to write man's height over man's shadow is equal to pole's height over pole's shadow. What you want is this. There's two things. We're labeling and then we're defining what we're looking for. So we're looking for height and shadow length. So as long as the heights match each other either horizontally like we did here or vertically like we did there, we're okay. And as long as who those heights and shadow lengths belong to match either vertically like here or horizontally, man next to man up here, our ratio is going to work. All right? So there's a lot of ways to set this up. And if we set it up this way, it'll work the same. Look, man's height, which we had as 6, man's shadow was X, equals pole's height, which was 90, over pole's shadow, which is 45. It's a little trickier here. Let's cross multiply to solve this. All right? So I have 45 times 6 is equal to 90 times X. Wow, 45 times 6 is 270, And then when I divide by 90, I once again get x equals 3. All right. As long as you line up like measurements. Proportions will be equal. All right, so let's do one more, and then we'll move to the next page. This is a 2-day lesson, but let's go ahead and do this right here. All right. Now, this one uses an example of a scale on a map. It's really hard to see there, but you got one in there, and it says 1 inch is 18 miles. And you're going to have to use your map because this came out kind of ugly. All right. It says a scale is a ratio of any length in a scale drawing or a scale model to the corresponding actual length. All right. So this is saying that, hey, we've got this scale drawing, and they're telling you that an inch is the actual length of 18 miles. A drawing uses a scale to represent an object as smaller or larger than the original object is a scale drawing. All right. Three-dimensional model uses a scale to represent an object as a smaller or larger than an actual object, right? Because if I want to draw a car on a piece of paper, there's no way a whole car will fit on the paper. But, right, that's making the car smaller. What if I want to draw an atom, right? So if I'm drawing an atom, well, we can't see an atom, so we're gonna enlarge it. So we can either enlarge or reduce something that we're trying to represent. This map obviously reduces something. So use a map for the following. The actual difference from Chicago to Evanston is 11.2 miles. What is the distance on the map? So the first thing you have to do is figure out the distance on the map. Well, the distance on this map is 1 inch to 18 miles. And then you're going to say, hey, well, if I'm going to figure out how many inches on the map, right, because we've got the map inches on top, let's put the actual miles on bottom. So we're going to compare 1 to 18 to the actual distance on the map. I guess that's not actual distance. Distance on the map to the actual distance, right, that the two towns are from apart. And then we can multiply both sides by 18 and get this. So the distance on the map is about 0.625 inches. Well, what if I was going to do this? It says the actual distance between North Chicago and Waukegan is 4 miles. What is the distance on the map? So we're going to do the same thing, right? First we pick a scale, right? The scale is 1 to 18, and it says let D be the distance on the map. Well, the map is on top, right? We're going to keep the map on top. We're going to keep the actual on bottom. So again, we're comparing the map, which is 1 to 18, right? That's the scale value of map to actual. And then we know, right, that it is actually 4 miles, and we're solving for the distance. All right. So there's a lot of ways to do this. I can cross multiply if I so like. So I could say this. Let's multiply by 4, because that's what they did. I'm multiplying by 4. Let's stay with it. So 4 times this cancels out, and we just get x. They wrote d because we're talking about distance. And 4 times this is, well, that's 4/18, which reduces to 2/9 of an inch. So it's 2/9 of an inch. All right. So using what we just did, I'm going to let you hit this scale model right here, and we'll do some practicing, but that's your first goal.